You know, we hear the words AI bias and unfair algorithms thrown around all the time. But what do they really mean? I mean, how do you actually prove it? To build AI that's truly fair, we can't just talk about it. We have to be able to measure it. So in this explainer, we're going to move past the buzzwords and get into the nitty-gritty of how you actually audit an algorithm for fairness.
And make no mistake, the stakes here are, well, they're incredibly high. We're talking about automated systems making calls every single day that can completely change the direction of someone's life. This isn't just about, getting the right movie recommendation. This is the big stuff.
I mean, just think about it. These algorithms are basically the new gatekeepers in our society. They're deciding who gets a loan to start that dream business, who even gets a foot in the door for a job interview, who gets flagged for crucial, life-saving medical screening, and even who gets a safe place to call home. The impact is so direct, and honestly, it's profound. And that right there is the core problem, isn't it? It's one thing to feel like a system is unfair, but it's a whole other challenge to actually prove it with data. How do you find that ghost in the machine? How do you take something as complex and, frankly, as human as fairness and measure it in a way that's concrete and gives you something you can actually act on?
Okay, so this is where we really move from just talking about it to actually doing something. To make AI fair, you have to define fairness in a way a computer can understand, in mathematical terms. We need solid, robust metrics that can tell us not just if a model is biased, but how it's biased and by how much. Is that hiring algorithm biased against a certain group by 5%, or is it a whopping 50%? We need to know.
And here's where it gets really interesting. It turns out there's no single one-size-fits-all definition of fair. It's not that simple. Instead, think of it like this. Data scientists have a whole toolkit of different metrics. They're like different lenses you can put on to see different kinds of unfairness. Each one is designed to spot a very specific type of problem. So let's take a look at the three big ones.
All right, first up is something called demographic parity. This one is probably the most straightforward to wrap your head around. It basically says that the outcome, let's say getting a loan approved, should happen at the exact same rate for all groups. So if 10% of men who apply get a loan, then 10% of women who apply should get one too. Period. Simple, right? Well, it's a great start, but as we're about to see, it can sometimes oversimplify things.
Okay, next up we have equalized odds. Now this one is a bit more nuanced. It doesn't just look at the final outcome, it looks at the mistakes the algorithm makes. So you have false positives, that's when the system says yes when it shouldn't have said no, like giving a loan to someone who ends up defaulting. Then you have false negatives, when it says no but should have said yes, like denying a loan to someone who would have paid it back perfectly. What equalized odds demands is this. Is the system making both types of mistakes at the same rate for all groups? It's all about making sure the burden of the algorithm's errors is shared equally.
And our third lens is equal opportunity. You can think of this one as a kind of middle ground. It zeroes in on one very important thing, the true positives, which are the people who are correctly approved. So it asks, of all the people who were actually qualified, the ones who really would have paid back that loan, did every group have the same chance of getting approved? This is all about making sure deserving people aren't unfairly left behind by the system's mistakes.
So, as you can see from this breakdown, each metric has its own strengths and weaknesses. It's all about trade-offs. Demographic parity? Super simple, but it might not be the right tool for every job. Equalized odds? It's really thorough about errors, but chasing that can sometimes lower the overall accuracy of the model. And equal opportunity is great for protecting qualified people, but it might not catch other kinds of negative bias. So, which one do you pick? Well, there's no easy answer. It really depends on the situation and what you decide is the most important ethical goal.
Okay, enough of the theory. Let's make this real. We're going to walk through a quick audit of a loan approval model, and you'll see firsthand this classic challenge that comes up all the time, the trade-off between fairness and accuracy. All right, so here's our baseline model. This is the algorithm a bank is currently using. We've run the numbers and, wow, look at that gap. The approval rate for men is a full 19 percentage points higher than it is for women. Using the metric we just talked about, that is a huge demographic parity problem. So what do? We go in, we use a fairness tool to retrain the model, basically telling it, hey, your main goal now is to close that gap. And check out the result. The new, what we call mitigated model, has practically erased that disparity. The difference is so small now, you can barely even see it on the chart. The gap in approval rates has shrunk from 19% all the way down to just 2%. That is a massive win for fairness. But, and this is the really crucial part, here's the trade-off. Let's look at the numbers side by side. To achieve that incredible improvement in fairness, the model's overall accuracy,
its ability to correctly predict who will pay back a loan dropped from 77% to 72%. That's a 5 percentage point drop. And this is the constant balancing act in responsible AI. It forces you to ask a tough question. How much accuracy are you willing to sacrifice for a fairer outcome?
Now, let's move from a lab example to a powerful real-world case study. This one is about public housing. So, a mid-sized city decides to automate its housing allocation system. The goal was great, right? Make things faster, more efficient, and more objective. But things definitely did not go as planned.
Pretty soon after this new system went live, local advocates started hearing the same story over and over again. People from specific neighborhoods, mostly lower income, historically minority communities, they felt like they were just being systematically shut out. They'd apply, and their applications would just vanish into this digital black box. No explanation.
So investigators launched a full forensic audit, and what they found was just stunning. It turned out the algorithm was using an applicant's current address as a huge factor in its decision. But here's the thing, that address was just acting as a stand-in, a proxy for race and poverty. It was basically encoding decades of housing segregation right into the new software. When they mapped it out, they found these cold zones where getting approved was almost impossible, and those zones lined up perfectly with the city's old, historically redlined neighborhood.
And what's so important to understand here is that the solution wasn't just about tweaking the code. That was part of it for sure. They retrained the model to weigh location less heavily. But the real fix was about building a system of accountability around it. They brought in civil rights groups to review it, they mandated public audits every year, and, this is huge, they created a formal process for people to appeal a decision made by the algorithm. And the result? It was immediate, and it was absolutely measurable. After all these changes were put in place, the housing success rate for people applying from those previously excluded neighborhoods doubled. It just goes to show that when you combine the right measurement tools with a real commitment to oversight, you can make a tangible, life-changing difference for people.
Now, it would be great if we could just say, okay, problem solved. But of course, it's not that simple. As powerful as these measurement tools are, this isn't a one-and-done fix. The real world is messy, and finding and fixing bias is a constant, ongoing challenge.
I mean, for starters, you need a lot of data. If you're looking at a really small group of people, it's tough to know if a difference in outcomes is actual bias or just random statistical noise. And context is everything, right? What you consider fair for a hiring algorithm is going to be totally different from what's fair in medical diagnostics. And maybe most importantly, these standard checks can sometimes miss what's called intersectional bias, the kind of double jeopardy faced by someone with multiple marginalized identities, like a black woman whose specific experience might be invisible if you're only checking for race and gender separately.
So we're left with this really fundamental tension. We now know we can measure fairness, and we can definitely measure accuracy. But as we've seen, sometimes pushing to improve one can actually hurt the other. And that leads us to a deep, really challenging question that I think every company, every government, every organization using AI has to grapple with. When you're faced with an algorithm that's accurate, that works by technical standards, but is also demonstrably unfair, which problem do you fix first?